Hello and welcome back to Geospatial Solutions. So this video is a part of the ArcPy series. So as you might recall, in our first video, we saw how to clip a certain amount of point features that fall within a particular polygon boundary and how to further filter it out using a condition. Uh, and we did all these steps by simply hard coding the parameters. And I hope you are aware of this concept of hard coding because I've already explained that in our previous video. So to be short and crisp, the main difference between hard coding and soft coding is in terms of hard coding the parameters, and the values of each and every parameter is already predefined. So these values are fixed and they can't be changed. But whereas in the case of soft coding, these values can be changed. That is, the software will be asking the user to feed in the values. So these values are user defined. So in terms of hard coding, the parameter values are predefined, whereas in terms of soft coding, the values are user defined. So with that being said, in this video, we're going to see how to soft code the parameters. So we're going to create a tool by soft coding the parameters, and the operation that we're going to do here is that it is more similar to the first one. So first we're going to clip some points that fall within a polygon, and these points will be filtered out based on a condition, and those filtered out points will be used to create a buffer around them. So first we're going to do clip and then select and then buffer. So this tool will be soft coded. First let me open the Python Win software. That is the software which we'll be using to write the code. So first let me create a new file here. So the first statement is by import ArcPy. This statement will be importing all kinds of commands from the ArcPy package. So this is the most important and the paramount step. So import ArcPy. So now I'm going to create a variable. So this variable name can be given of. So this variable can be given a name of your choice. So let me give the name as input FC. FC in the sense feature class. Input FC is equal to. So this variable will be fed by the user. So this variable will not be hard coded; it is soft coded, right? So it will be asked. It will be asked by the system. So for that, you have to give the statement here as ArcPy dot get parameter as text, right? And more importantly, you have to make sure that this particular statement is case sensitive. So all those G, P, A, and T should be in caps. And then you have to give this value here. You have to enclose this value inside this parenthesis. So since this being the first variable, so the value should be given as 0. So now we are given the input feature class. So now we have to give the boundary based on which the clip will be carried out. So for that, let me give the clip feature boundary as clip boundary. Clip bound is equal to, you have to write out the same statement again. So it will be ArcPy dot. You can just press tab, open parenthesis, 1, and then close. So now we are given the input feature class as well as the boundary. So now we have to give the output shapefile. That is, you have to save this file, right? So for that you have to give a name. So it will be given as clipped feature, clipped underscore feature. Maybe FC would be fine. Clipped FC is equal to ArcPy dot get parameter, open bracket, 2, close bracket. So we are given all the parameters that are required to perform a clip analysis. So now we can write the clip function here. So it is ArcPy dot clip underscore analysis, open brackets, input FC, clip, bound. So these were the names are given. So it is based on your name. It is based on whatever name you have given. So it will be input FC, comma clip bound, comma it is clipped FC, right? Clipped FC. And then close the bracket here. So with this we have completed the clip process here. So the next step is we have to do the select operation. So for that, first let us create a new output feature class. So it will be given as select cell underscore FC is equal to ArcPy dot get parameter as text. So all these numbers should be in a sequential order. So it will be 3 here. So what this statement means is that it will be asking us for the place where this file should be stored, right? So select feature will be stored based on the location which we specify. So that is done. So now we have to give the condition. So let me give the condition's name as expression. Expression is equal to ArcPy dot get parameter as text, open bracket, 4, close the bracket. So we are given the condition as well as the output feature class. So now we can do the analysis. So for that, ArcPy dot select underscore analysis, open bracket. So this tool will be using the output of the previous tool, right? So it will be using this parameter as the input for this tool. So we have to give the name of this shapefile here, right? So it will be clipped underscore FC. That is the input feature class, comma, and then the output feature class. So the output feature class is this one, that is the cell underscore FC. So clipped underscore FC is the input file, and the cell underscore FC is the output file. So it is cell underscore FC, comma the expression. Right. So we have done both the clip as well as the select operations here. So the next thing is you have to do the buffer. So for that, let me create another variable in the name output buffer, op underscore buffer is equal to ArcPy dot get parameter as text, open brackets, and the value will be 5 here. So it will be 5. So it will be 5, close brackets. So output buffer, we have created a variable, and this variable will be user defined. So the next thing is we have to specify the distance for this buffer, right? So it will be distance is equal to ArcPy dot get parameter as text, open brackets, 6, close the bracket. Now you have to perform the tool ArcPy. It will be ArcPy dot buffer underscore analysis, open bracket. So you have to give the input file here. So the input file here is cell underscore FC, right? So it is the output of this particular tool. So it is the input of this buffer operation here. So it is cell underscore FC, comma, and then the output buffer output file. So it will be op underscore buffer, comma, distance, right? So you can close the bracket here. So I suppose you have created, we have written the code properly here. So I think it's done here. So you can just save it. So just save it. Let me just give the name as CSB, so that it represents clip, select, and buffer. CSB for Python. So let me just save it. Okay, so it has been saved here. It has been saved. So the next step is we have to import this script file into our ArcMap software. So let me go to the ArcMap software again. So I'm just going to create a new folder. Just creating a new folder here. As tools. Okay. Right click on the folder, then go to new toolbox. Okay. So let me give the toolbox name as Python toolbox. Python. Okay. Right click it again. Right click the toolbox. Then go to add script. So you'll be getting a box like this. So in the script name, you have to give a name here. So let me give the name as CSP itself. Let me give an elaborate name here, because this label will be appearing in our tool. So it has to be a bit expressive. So let me give the name as clip and select and buffer. Right? And you can also give a description of your tool. So this tool clips, selects and buffers points based on user specified values, right? Something like that. It is up to you. Okay. So after giving the name, label, and description, you can just click on next. I mean, it's not compulsory, it is based on your discretion. You can just click on next. So in this step, you have to import the script file which you have created. Okay, so just open the folder here. Just import that file inside this. Okay, just click on next. And as you can see here, this is the page in which you have to soft code the parameters, right? So first, we have to give the parameters names here. Okay. So let me just open the script file so that we can have a look of it. So this is the script file. So the first one which you have given here is input feature class, right? So it is not mandatory to give the name as it is. It is based on a wish. You can give whichever a name you want. So let me give the name as input feature. Input feature, right? And then you have to specify the data type. So the data type for this is shapefile. So just go to the shapefile option here. You can see here. Okay, it's done. And then you have to check for these parameter properties. So in this case, we're going to give this input feature as the input, right? So it will be input, and the type is required. I mean, it is mandatory. So the type will be required, and the direction will be input for this particular parameter, right? So we can move on to the next one. So the next one which you have given here is it is the clipping a polygon boundary. So you can give the name here. So let me give the name as clip boundary. Clip boundary. And the data type as shapefile. Shapefile. And the type is required. A direction is also input for this. So there is no need to change anything. Okay. So we can just move on to the next one. So the next one is clip to feature class. So this one is the output which you have to specify. So let me give the name as clip to feature. Clip feature. Data type is shapefile. Okay. So in the next one, so the important thing to do here is that this clipped feature is a output file. It is the output file. So we have to give the direction here as a output. Since we are going to specify the folder path for this particular file, so we have to give the direction as output for this file. It is very important to note this process. Okay, so it is output. And then the next one. So you can go to the next one. So the next one is select feature, right? So it is select feature. So you have to just specify that again. So let me give the name as selected features. Selected features. Okay. And the type as shapefile itself. Type as shapefile. Okay. Shapefile. So the selected features is also an output file, because you have to specify the folder path for this. So you just have to change the direction to output here. So just change the direction to output here. So it is also output. So let me go to the next one. So the next one is expression. For expression, let me give the name as condition. Condition. So for this, type is SQL expression. So for that, you have to just type in SQL expression. Since it is a condition, it should be given as SQL expression. Okay. Let me just change this letter to caps here. Okay. So selected features condition. This condition is also the input file, input statement. So these two things are fine here. Type is required and direction is input. An important thing here is that this condition should be based on the input feature, right? Because it has to specify the fields in the input feature. So for that, just go down, go to this particular section here, obtained from input feature. So you have to give this. This thing is also very important. Okay. So the next thing is parameter is output buffer. So output buffer and distance, right? So the next one is output buffer. So let me give the name as output or as buffer. Buffer, okay. Shapefile is the data type for this. Shapefile, okay, shapefile. And next one is the distance. So the distance. So the data type for distance is linear units. It will be linear units. Linear units, right? So let's have a small recap here. So the first one is input feature. So the input features type is required, direction is input. It's fine. For clip, it is required and input. It's fine. For clip to feature, it is the output direction. It's fine. Selected also, it is the output. And for condition, it is the input. And it should be obtained from the input feature here. And then for buffer, it has to be output, right? So you have to change this to output here. So buffer, it is the output file. Since we are going to save it, it should be given as the output file. And for distance, it is fine. Type is required, direction is input. So I suppose everything is fine here. You can just move on to the next step. Just click on finish. As you can see here, we have got the tool here. Just check it by running it. Let me open it again. So the first box, you have to give the input feature. So input feature in the sense, you have to give the point features. So let me give a point feature, point shapefile here. So there is the point shapefile which I'm going to give, and then I'm going to give the clip boundary. So the clip boundary here is the district of Chamoli. So this district is in Uttarakhand state in India. So I'm just going to give this as the clip boundary based on which the clip operation is going to be done. So just add it, clip boundary, and then you have to save the output clip to file, clip to points. So let me give the name as clip _bts.shp, right? So just save it, and then you have to give the output file for the selected features. So for selected features also I need to give a name. So let me give the name as cell_pts.shp. Right? So now you have to specify the condition. So for that, just press this button here. So as you can see, it has been listed out here. So all the field names that reside within this point shapefield is displayed here. So I'm going to filter this point data based on the type category. So let me just include this inside this box. So it will be type is equal to ATM. ATM will be fine. So what it is going to do is that it is going to display only the ATMs that are falling within this shapefile, that is the Chamoli district boundary. Right, clear? So let me just click OK here. A condition is specified. So now you have to specify the buffer file. So let me give the buffer name as cell_buff shp to one save. So now you have to specify the units. So let me give the value as 2 kilometers. Okay, so 2 kilometers around the 2 kilometers around the selected point features. Okay, so I suppose everything is fine here. So input is fine, clip boundary is fine, clip feature is fine, selected features type as ATM for. Okay, so let's run it. And so as you can see, it's run, and so these were the points that were inside the Chamoli district boundary. So let me open the Chamoli district first. So this is the district boundary. So as you can see, all these points are clipped within this particular extent, and these were the points that are selected based on the condition that is given. Okay, so let me just uncheck this, and also uncheck this. So as you can see, these 2 points are the ATMs. So we can also cross check it. Just opening the attribute table. So you can see the type here. So these 2 points are ATM points. And you can also see the buffer that has been created around these 2 points. In order to verify it again, you can just zoom it and measure the distance, right? So just zoom it. Let me just measure the distance for this particular point here. So go to measure. So perfect. So distance which we gave is 2 kilometers, right? So it is showing us 2000 meters. So it's fine. So with this, we have done how to create a tool, how to just customize a tool, and how to build it, right? And if you do not wish to show these clipped points that are falling within this boundary, and if you wish to show only the selected points and then the created buffers, that is like this. If you do not wish to show the clipped points, and as soon as you finish running the tool, if you want to display only the selected points and as well as the buffer that is created around them, there is an alternate way for that. So let me show you how to do that. So for that, you just have to go to your folder again in which you created this tool. So let me open the tool again here. So you just have to right click on the tool here and then go to edit. So as soon as you click that, you'll be getting this notepad file in which the code is written. So we just have to tweak some things here. So for that, what we are going to do here is that they want to remove this particular statement because this statement is asking us to save this clipped points, but we don't need to do that step since we want to display only selected points and their buffers. So for that, we can just remove this. Before doing that, let me create another statement here. So let me give another statement like this: clipped fc is equal to r open double quotes, right, in memory backward slash, right, just give a name, okay, clip pps, right. So now we can remove this statement. So this statement is unnecessary now. So you can just remove this, right? So now we have to just rearrange the sequential order of these numbers. So it is 0, 1. So this 3 will be 2 now. This 4 will be 3 now. So in the same manner. So this 5 will be 4 and this 6 will be 5. Okay. So what I have done here is that I have asked the system to store this particular clipped points in the virtual memory. So this particular shapefile won't be saved in the system as a permanent file. It will be saved only as a temporary file. So as soon as this entire tool is run, this file will be deleted, right? So this file is a temporary one, and it will be stored as a virtual file. Okay. So that is the reason I have given this statement as in memory. It will be stored only in the memory, and it won't be saved permanently. And one more thing you have to note here is that you just need to give the name of this file. Okay, there is no need to give the extension, because you've already given the extension as shapefile in our parameter properties. Okay, I hope you remember that. So there is no need to give the extension here. It is fine to give the name itself, right? So now save it now. So let me just check it again. So it is 0, 1, 2, 3, 4, 5, and the clipped feature will be saved in memory as clip_pts. So this clip feature will be used here, and it will be doing the same process. Okay, so it's done now. You can just save it. And you can just close it. Before rerunning the tool, first you have to edit the parameters. So just right click on the tool here, and then go to properties, go to parameters tab. So now we have to delete this particular parameter, because this parameter is of no use now. Since you have deleted this parameter in the code, there is no need to use this parameter here. So we can just delete this parameter. So for that, just click on it and then press delete. So it will be deleted. So you can just press delete now. Okay. So it's done now. You can just click on apply and click OK. So if you just rerun the tool again now, you can see the difference here. It is not asking for the clipped output feature. It is not asking us to save it, because you've already removed it from your code as well as in the parameter tab. Understood? So you just have to do the process again now. So let me just give the input feature as points again, points, and the clip boundary as Chamoli. Okay. The selected features as cell PTS1. Since you've already created one shapefile in the same name, so it will be cell PTS1.shp. Okay, so give save, and condition will be type is equal to ATM. Okay, so it's buffer cell_buff1.shp. Save. So distance will be 2 kilometers. So 2 kilometers. Okay. So everything is fine here. It should run fine now. So click on OK. So it's done. So as you can see here, it is displaying only the cell PTS1 and the cell buff1, right? These three things are the ones which we created in our previous tool, right? So we can just remove them. So it has created only the cell buff1 and the cell PTS1. Let me just make it transparent here, so that you can have a better look at it. The cell PTS1, I'll give the color as yellow, and you can see the difference here. Cell buff1 will be in the color red. Okay. So you can see the difference here. It is only giving us the two output files. Okay, the first one being selected points, and the second one being the buffer around those selected points. You can also check the measurement again here. So just click on this. You can see as you can see, it is the same. Okay, so In this we can create a lots of tools here. Lots of tools can be done using the ArcPy language here, and all these tools can be soft coded. So this video is just a starting point. Uh, as you'll be seeing lots of raster based analysis in our future videos. So you'll be seeing how to customize some tools so that you can get some raster outputs. So please do subscribe my channel, and please do like, share. It will be of immense help for me. So thank you so much for watching.